Hi friends, welcome to the lecture. Now, today we will see what is the elementary transformations on a matrix. So, we have to see what are the elementary transformations on any particular matrices. First one is the interchange of, actually there are total six elementary transformation elementary transformations. Out of six, three are of rows and remaining are of column. So first one is interchange of the interchange of any two row or column of the interchange of any two row or two columns. In this method, if we interchange the ith and jth row of a matrix, the the original matrix original matrix is transformed into a new matrix, and symbolically we denote it by symbolically it is denoted by row rith row is interchanged with jth row or rij, that is ith row is now jth and jth row is now ith row. Similarly the column, if we interchange if we interchange the fifth column with nth column, then it is symbolically denoted by is symbolically denoted by CKL or eighth column interchange with twelfth column. Okay, and R and C denotes R and C denotes the row and column respectively. Okay, now we have to see what is a interchange of any two rows or columns of a matrix. That is, if we interchange the ith row and jth row of a matrix, suppose A is a matrix and we interchange the ith row and jth row of a matrix, then the original matrix is changed into new matrix, since ith row is now jth row and jth row is now ith row, and we symbolically it is denoted by Ri changing to Rj, or it is simply a Rij. Similarly, we interchange the kth column and lth column, then symbolically it is denoted by CKL or CK is changing to CL. So this one is the interchange of any two row or column. That is, in this method there are two out of six elementary transformation. Two are here. One is of row transformation and another is a column transformation. So there is important note: a row cannot be interchanged with cannot be interchanged with a column interchanged with a column and a column cannot be interchanged with cannot be interchanged with row. That is, if we interchange the rows, if we have to interchange the row, then we have to must interchange with a row itself. Since if we there is no possible transformation in between rows and column, that is we interchange any row with a column or any column with a row. It is not possible. If we have to interchange the row, then we have to interchange it is with row only. Okay, now let us take some examples. Let ABO matrix, let A equal to 1 2 3 and 4. Here it is a matrix of order 2 cross 2. So there are two rows and two columns. This one is the R1, R1 is 1 2, and R2 is 3 4, and C1 is 1 2, and C2 is 2 4. Now, if suppose we have to interchange first row with a second row, then we have to take this second row as a first row and first row as a second row. We get A dash, we get a new matrix A dash will be equal to 3 4 1 2. Similarly, if we have to change C1 to C2 in matrix A, in matrix A, then the corresponding row transformation sum B is equal, sorry, column transformation sum B is equal to, we have to make the second column as a first and first row as a second. Then we get 2 4 and 1. So this one is the interchange of any two row or any two columns of a given matrix. Now the second method is the multiplication of elements of elements of any row or column by a non-zero scalar. In this method also there are two transformation. One is on row and another is on column. Okay. Let k be any non-zero scalar. Let k be any non-zero means it is not equal to 0. Be a any scalar. Now, suppose we have to multiply. If suppose A be a given matrix which contains three rows and three columns, and we have to multiply the third row by some non-zero scalar k. Then we denote it by, that is, if A is matrix of order 3 by 3, that is, and now we have to multiply the third row which is denoted by R3. By the third row by K, we denote it by, we denote as the third row R3 is gets changed to K times R3. Okay, so the third row is now K times the third row itself. Okay, now suppose example, if A is a matrix which contains four elements A, B, C, D, and now we have to multiply the second row by K, then we get, here we have to apply a transformation R2, which changed to K times R2. Then we have to multiply this C by K and D by K. Then we get some new matrix B, and which is equal to A, B, K into C and K into D. Similarly, we can apply this method on a column transformation also. That is, if suppose we have to make the first column as a K times the first column. Then we have to multiply this A and C as a by K. Then we get some new matrix C, which is equal to KA, B, KC. Okay. Now the third type is third one. This method also, that is this transformation also includes two types again. That is two element transformations. The addition of elements of any row or column by the corresponding elements of corresponding multiples of elements of any other row or any other column. So, in this method, if we have to add elements of any row with the elements of some multiples of any other row, then we have to apply the following method. If suppose K is a non-zero scalar, zero scalar, and AB any matrix of order n cross n. Now we have to interchange the first row to the three times of R. That is, we have to add first row with the K times the second row. Then this transformation is denoted by R1 plus KR2. Similarly, we have to interchange the first column to the K times the first column to the sum of first column with the K times the second column. So this is denoted by this symbol. Now, if suppose A is a matrix which contains 1, 2, 3, 4. Now it is a 2 cross 2 matrix, then it includes two rows and in column. Now, if suppose we have to interchange the first row to the R1 plus 2 times R2, then we get some new matrix B which is equal to, now there is only change in the first row and second row remains as it is 3, 4. Now first row 1 plus 2 times R2, 1 plus 3, sorry 2 times R2, 3 into 2 6, 6 plus 1 7. Similarly, 2 plus 2 times 4. 4 into 2, 8. 8 plus 2, 10. So this one is the corresponding matrix by applying this row transformation. Similarly, we can apply this method on a column also. Now, inverse of a matrix. Here, let A be any matrix of order m, and there exists a matrix B of same order such that matrix A into matrix B equal to B into A equal to I, where I is the identity matrix of order M, where I is the identity matrix, that is unit matrix of order M. Then we say that the matrix B is inverse of the matrix A. Then we say that matrix B is inverse of matrix A, and it is denoted by A to the power minus 1. As B is denoted by A to the power minus 1, then we get A into A inverse equal to A inverse into A, and which is equal to I. And if B is the inverse of A, then A is the inverse of B. Okay. Now, suppose if there is one matrix A which is equal to 2, comma 3, sorry, 2, 3, 1, 2 is a matrix of order 2 cross 2. Now, we have to find out the its inverse. Suppose B is another matrix which is equal to 2 minus 3 minus 1, 2. Now, we have to check whether this matrix B is an inverse of that matrix A. If B is said to be an inverse of A, if order of B is same as order of A, and A into B will be equal to B into A equal to identity matrix of that order. Now check A into B. A into B equal to 2, 3, 1, 2 into 2 minus 3 minus 1, which is equal 2 into 2, 4, 3 minus 3, 2 into minus 3 minus 6, 3 into 2 plus 6, 1 into 2, 2 minus 1, minus 3 plus 4. So which is equal to 4 minus 3, 1, minus 6 plus 0, 2 minus 2, 0, minus 3 plus 4, again 1. So here we get the identity matrix of order. Now check whether B into A is also I or not. B into A equal to 2 minus 3, 1, minus 1, 2, and 2, 3, 1, 2, which is equal to 2 into 2, 4, minus 3, 2 into 3, 6, minus 6, minus 2, plus minus 3, plus 4. So which is equal to again 4 minus 3, 1, 6 minus 6, 0, minus 2 plus 2, 0, minus 2 plus 4, 1. So which is equal to I. So here we get A into B equal to B into A equal to I. So from this we says that matrix B is inverse of a matrix A, and we can denote this matrix B as A inverse. And if B is the inverse of A, similarly A is the inverse of B. Okay? And inverse of a matrix is to find out the inverse of a matrix A must be a singular matrix. Actually, we know that what is a singular matrix. A matrix is said to be a singular matrix if its determinant is non-zero, and if its determinant is zero, and if the determinant is non-zero, then the corresponding matrix is said to be a non-singular matrix. So, matrix is find out if only if the corresponding matrix is a non-singular matrix. If it is singular matrix, then it is not possible to find out the inverse of that matrix. Now, there is method. Inverse of a matrix. Inverse of a matrix by elementary transformations. So here we have to find out the inverse of matrix by using the elementary transformations. For if suppose A is a non-singular matrix, A is a non-singular matrix, it must be given since inverse is, we can find out the inverse if and only if A is a non-singular matrix. Otherwise, it is not possible to find out the inverse of that matrix. As A is non-singular, then now A is, we can find out the inverse of that matrix A. Now here, if A is a matrix, suppose equal to A11, A is a matrix of order 3 cross 3. A equal to A11, A12, A1, A31, A32, whatever may be, sorry, A21, A22, and A23, A31, A32. It is a square matrix of order 3 cross 3. And for inverse of a matrix must be a square matrix. So A equal to A11, A12, A13, A21, A22, A23, and third row is A31, A32, A33. Now we have to find out the inverse of that matrix. If and A is a non-singular matrix. Now, if we have to find out this matrix, find out the inverse of that matrix, then we have to reduce A11 transformations used to find out the inverse. Actually, here we have to check whether A into B is equal to I, since B is the inverse of A. Now, if suppose A is a matrix of that form, now we have to reduce this matrix A as a identity matrix. If we have to reduce this matrix as an identity matrix, then we have to make this entry as a equal to 1, and the remaining two entries A21 and A31 will be equal to 0. Similarly, we have to make A12 and A32 will be equal to 0, and A22 will be equal to 1, and A13, A23 will be equal to 0, and A33 equal to 1. So we have to reduce A11 as A11 to 1, reduce, then reduce they reduce A21 and A31 to 0. Similarly, reduce A22 to 1, and then reduce A12 and A32 to 0. Similarly, reduce A33 equal to 1, and reduce A13 and 8, 2, 3. Okay. These are the transformation to find out the inverse of a matrix. Actually, this one is the not the method to find out. These are the only transformation. There is one method to find out the inverse of a matrix by transformation. Now, we will take one example and see what is the method. Now, which of the following matrices are invertible? There are some examples for it. 2, 1, 4, 2. 2, 3, 1, 2. 1, 2, 3, 1, 2. So now we have to check which of these three matrices are invertible matrices. And we know that the matrix is said to be an invertible matrix if and only if it is a non-singular matrix. So we check whether a matrix is singular or non-singular. Now from this we conclude that whether the corresponding matrix is invertible or not. For first matrix, A is given as 2, 1, 4, 2. So determinant of A is denoted by this one and which is equal to 2, 1, 4, 2. And how will you find out the determinant? 2 into 2 will be equal to 4 minus 4 into 1 is equal to 4 which is equal to 0 which implies A is singular. And it as it is a singular matrix then this matrix is not a invertible matrix which implies A is not invertible. Now second one is matrix B. B equal to 2, 3, 1, 2. Find out its determinant. Determinant of matrix B equal to 2, 3, 1, 2. And which is equal to 2 into 4 minus 3 and which is equal to 1 which is not equal to 0 which implies B is a non-singular matrix. As B is non-singular, it implies B is a invertible matrix which implies B is invertible. Now we have to check the last one. Matrix C. C equal to 1, 3, 2, 3, 1, 2 and 1, 2, 3. Now determinant of C is equal to 1, 3, 2, 3, 1, 2 and 1, 2 which is equal to 1 into 1 into 3 minus 4 minus of 3 into 9 minus 2 plus 2 into 6 minus 1 which is equal to 1 into 3 minus 4 minus 1 minus 3 into 9 minus 2 7 plus 2 into 5 which is equal to minus 1 minus 21 plus 10 which is equal to minus of 22 plus 10 and which is equal to minus 12 and which is not equal to 0. As it is not equal to 0 then C is a non-singular matrix and C is not singular which implies C is invertible. Okay, thank you for watching the lecture.